Hey guys, so today we'll actually go to another part of partial derivatives, right? So we'll be dealing with something called successive differentiation. So let me just write that down. Whoops. Okay, so better, right? So successive differentiation, right? So what is successive differentiation? Differentiation. Okay, right. Hopefully you can see that clearly. So that is mean to say, for example, we have a function as f, x, y, z. All right? And we do the partial derivative with respect to x. Del f, del x. Okay? Or maybe we do del f, del y. Right? And we take the del f, del z. Right? With respect to x, y, and z. Okay? Let me use a different color for this. So let's say I take another derivative of this with respect to x, so another del dx. So what happens, okay, if I take another del dx of del f over del x. So this is going to, of course, result us in finding the x derivative of del f del x, but we can also write it as del square f del square x. Oh, sorry, I mean del x squared, my bad. Del x squared. Just like, for example, how you normally have a function of y in terms of y in terms of a function of x, and then you do dy dx for the first derivative, and for the second order you do d square y dx square, right? So this is like the first order, and this is obviously the second order, right? The second order of derivative. So we also have a similar thing for partial differentiation. We also have del square f del x squared. Similarly, if we also take the del f del y with respect to del y, we'll also have del square f del y squared. Okay. Likewise also for this, right? We have del square f del z squared. All right. So with these three examples I've given here, so these are example of successive differentiation, but there are also more examples. All right, so let me just erase this real quick. Okay, let me just erase this part. Sometimes, because these equations are all multiple variables, right? So that sometimes you could also, right, let me write like this. You can also differentiate it with respect to y. So if you have del y, so you'd have here del square f, right? Del y over del x. Okay, so the del x, obviously, as you know, it means that this del x obviously it was already written as del f del x. It was already differentiated first, and this one came later. So this one actually sort of came later. All right. So likewise, the same also goes for del f del y. Sometimes you can also write it as, if you want to differentiate del f del y, let's say with respect to uh del x. So you'll also have del square f del x del y. So obviously this del y refers to the initial differentiation we did, del f over del y, and this one obviously came much later than that. All right. So that is the idea of successive differentiation. One more thing I'd like to clarify is that del square f, right, del y, del x is not always the same with del square f, del x, del y. Okay, so this is sometimes I'll say not always. Okay, so this is not something that happens always. Okay, it depends on the function. Okay, so it depends on the function actually. This one will technically depend on function. Okay, this depends on function. Okay, all right. So with that being said, let's just do some practice questions from the textbook. Right, I'm gonna have to erase this off real quick. Let me just erase it real quick. Okay. Okay, so I already erase it off real quick. Now let's do some questions from the textbook. I haven't erased this part yet. Whoops. Forgot to erase the title actually. Okay, great. So let's proceed with some questions. So we have a question from the textbook that actually asks us to verify. So it asks us to verify verify that f with respect to x with respect to y is equal to x over x squared plus y squared. Okay, so x squared plus y squared. You have to verify that this equation satisfies, okay, so it has to satisfy something, satisfies, right? So it has to satisfy del square f over del x square plus del square f over del y square is equals to 0. Okay, so what we have to do, of course, we'll have to find the derivative of del x, obviously del f del x, and then later we also have to find a second time. We have to obviously uh find the del x over del f del x, right? Likewise, the same also for this. Find del f over del y, then you find the del y over del f del y. Okay, so once you do these two, obviously you can make sure that they are 0. Okay, so let's start first. Let's just try to find the derivatives, the partial derivatives of these two. Okay, so first we find del f del x. Okay, so to find del f del x, we have to actually see that our function has, in terms of two components, right? A numerator u and of course v. So this obviously calls for product quotient rule. So it is v square, sorry, not v square, v du dx minus u dv dx over v square. So it is of course x square plus y square. Du dx is 1 minus u, okay, x. dv dx is just simply 2x because y is just a constant over v square, which is just simply x square plus y square squared. If you were to simplify, it becomes x squared minus 2x squared becomes negative x squared plus y squared over x squared plus y squared squared. Okay, so that's your del f del x. Okay, So I'm going to obviously erase it for space purposes. All right, and just rewrite the equation right here. So it's just negative x squared plus y squared over x squared plus y squared squared. That is your del f del x. So we already found del f del x. Now we need to find del square f del x squared. So again, we have to differentiate del f del x with respect to x. So I'm going to use a different color for now. Gonna write this as my u. I'm gonna write this as my v. Okay, and I'm gonna do the same thing again. We're gonna have to obviously use the quotient rule. So v du dx. Normally, it'd be preferable to write del u, by the way. I should be writing del u, honestly, because we have multivariable, but yeah, in my head, sometimes I end up writing in du dx, actually. So yeah, so del u del x minus v squared. So in this case, it would be what? So v is obviously x squared plus y squared to the power of 2. Del u del x is what? Is just negative 2x minus u is just simply negative x squared plus y squared. And del v del x is just simply uh 2, okay, x squared plus y squared, obviously, right? And multiply with 2x, okay, over v square is, so you square that by 2 would be x square plus y square squared will obviously be to the power of 4. Okay, so if you were to simplify that, I'm going to draw an arrow right here. Actually, I know it's gonna be a bit messy. Bear with me on this one. So it would be what? Let me see here. Negative 2x x square plus y square squared. Okay, give 2x x squared plus y squared squared minus what here could become negative 2 becomes 4x. So minus, it would be here 4x. Okay, uh negative x squared plus y squared and x squared plus y squared. Okay, so hopefully it makes sense, because this 2 times 2 becomes 4x, x squared plus y squared, negative x plus y squared. Okay, and yeah, we're just gonna write that down with respect to x squared plus y squared. Okay, you can simplify this a bit, actually. So I'll just write it as negative 2x x squared plus y squared to the power of 2 minus 4x. Because it's just simply a formation, or the rule of what? If you guys remember this rule, actually, that if you have a plus b and a minus b, it's just simply a squared minus b squared. Yeah, so the same thing also can apply to here, actually. Right, the same thing applies to here. So I'm gonna obviously write it as y to the power of 4 minus x to the power of 4. Okay, hopefully that makes more sense. Over x squared plus y squared to the power of 4. Okay, with that being said, I know space is very limited, so I do apologize for it being a bit messy. So I'm gonna erase del f del x. Okay, we don't really need del f del x anymore. Right. I'm gonna write down the new answer here. Pen. Okay. So therefore, del f del sorry. Um, del square f del x squared is equivalent to negative negative 2x. Oh, see, I think we don't have space also. Oh my god. So let's erase all this real quick. Okay. Okay, it's just negative 2x x squared plus y squared. Okay, to the power of 2, right? Minus 4x y to the power of 4 x to the power of 4 over x squared plus y squared to the power of 4. Okay, so okay. With that being said, so we already found out del square f del x squared. Now how about the case of del f and del y? Okay, let's find out first. Let me read something else so it's distracting. Okay, great. So del f del y, we're only just worried about the bottom part. Let me just highlight it, it's circled in green for you. So we're really just interested in the bottom part here. So the top part doesn't really interest us anymore. So quite frankly, it's just a constant. So I'm just gonna leave it as it is. X, okay, and obviously this will be multiplied by, whoops, this will be multiplied by negative x squared plus y squared to the power of negative 2 times 2y. So in other words, it's just simply negative 2xy over x squared plus y squared to the power of 2. Okay? Now what about del square f del y squared? Okay. So to differentiate y again for the second time, and now this time we have to worry about the two components. We have to worry about the u and the v. So we have to also do another quotient rule, right? So be v del u del y minus u del v over del y over v squared. Okay, that's gonna be a very long number right here. So it's gonna be x squared plus y squared squared times negative 2x. Okay, del u del y is very straightforward. Minus negative 2xy del v del y. So del v del y is just, well, it's gonna be 2x squared plus y squared, right? 2x squared plus y squared, and multiplied with what else? 2x squared plus y squared, and then we have 2y. Okay, yep. Over again x squared plus y squared to the power of 4. Okay, so as we can see, it's almost getting very similar to what we see actually for the previous the del square f del x square. Very similar. So I'm not having much space, unfortunately. Let me just write it here. So become negative 2 x squared plus y squared to the power of 2 minus 2xy times that's 4. Actually, no, minus becomes plus, right? So plus 4 y squared x times. Oh, sorry, I forgot to put the 2x here. Let me reduce the eraser real quick. It was bothered me just now. 2x, x squared plus y squared root 2. 4 x y squared x. Okay. Well, 4 times 2 would have been about. Let me check. So 4 times 2 would have been about. Because you have your 2, you have your 2, and you have your 2. So that'll become 8. Okay. That'll be 8. 8 y squared x. Okay. Plus times x squared plus y squared. Okay. And then you'll actually have here x. You'll have here x squared plus y squared to the power of 4. Okay, so that's what we ended up having, by the way. Hmm. But the equations are not the same, unfortunately. They don't really seem to cancel out. That is quite concerning. Hmm. 4x. That means something is wrong with our del square f del x or our del square of del y, but I don't think our del square or del f del y is wrong. Let me just double check before I investigate x. Let me just check with a different colored pen. Sometimes these mistakes are bound to happen, so it's quite common to check first. So for del f del y, it's just simply x times negative, okay, of course, x squared plus y squared to the power of negative 2. Okay, so that's fairly correct, by the way, because it's negative 1 times, you differentiate the y only because x is not considered, so it's 2y. So it's just negative 2xy over x squared plus y squared to the power of 2. Okay, sounds fair enough to me. Then for del square f del y squared, obviously we took out the v, so it becomes x squared plus y squared to the power of 2 times du dy. Del u del y is just simply just 2x. So it's just negative 2x. So it becomes negative 2x x squared plus y squared to the power of 2, which is okay, correct. Then minus u is just simply 2xy, so it's just 2xy, and del v del y is just simply 2 bracket x squared plus y squared to the power of 1 times 2y, right? So how much is that going to be? That's obviously going to be 2 times 2y, so it's obviously 4y right here, so it becomes 4y straight away. And 4y times, well, negative 2xy becomes what? It becomes negative 8xy squared, right? So yeah, so this is actually perfectly okay. And this is x squared plus y squared. You of course, if you squared it right, you obviously become to the power of 4. So therefore, I think this is a fairly good answer. So I think we have to go check on our x. So I'm gonna have to erase this part obviously, and we have to check on our x. I think we made an arithmetic mistake here, so I'm gonna have to check on that first. Right, and we check on x. So obviously del f del x, because x has two parts, which actually makes this a little tricky. The of course we have the u and we have the v, right? So we have to obviously do the quotient rule. Okay, I'm not writing the quotient rule again because I do already know what the quotient rule is. So it is v, right, v del u del x minus u del v del x. So it's just times 2x, right, del v del x over v square. So v square is obviously x square plus y square to the power of 2. So it's obviously going to be x square plus y square minus 2x square, okay, over this. So x square plus y square to the power of 2. So it's just simply negative x square plus y square over x square plus y square to the power of 2. Okay, so I'm gonna erase that first, right? So I think this sounds about quite right. So I'm gonna have to also put this in. Okay, x square plus y square, x square plus y square to the power of 2. Okay, so now u v. So now when we try to solve for del square f del x squared. By the way, this is a del square f del y squared, yeah? I'm gonna write it here actually. Del square f del y squared. Okay. I'm sorry for all the messiness here because, when something is wrong, I have to actually erase all of this and try to address the problem. So this might take a little bit of time. All right. So yeah, apologies for that. So same thing again. It's just simply v. So just x square plus y square to the power of 2 times del u del x is just negative 2x minus y square minus x square. Del v del x is just simply 2x square plus y square times 2x. Okay, over x square plus y square to the power of 4. Okay, let's see what happens here. Right. So clearly it's negative 2x, right? Negative 2x x square plus y square to the power of 2. Okay. And we have here minus, let's see here. So 2 times 2 is 4. So 2 times 2 is clearly 4 here. It's supposedly 4, right? Yeah. Because 2 times 2 is 4. Yeah. So it's 4x, right? 4x. So, hmm. Okay. Seems like everything is correct here actually. So we end up getting here 4x. Yeah, and then of course when you have let me just highlight in green or white. When you have a function like this, x plus y square and y minus x square, x plus y square can be rearranged to y square plus x square. So of course you'll end up having y to the power of 4 minus x to the power of 4. Okay, so I don't obviously give it in, right? So become y to the power of 4 and x to the power of 4, so it's y to the power of 4 minus x to the power of 4 over the same denominator. So x squared plus y squared to the power of 4. Okay. So interesting. So it means that our del square f del x square is correct. Okay, so let's actually add and see what happens. I think maybe I didn't try to add and I didn't see what actually happened. Let's see the bigger picture here. Okay, let's try again. So if we add together, right? So what happens is that if we add up together del square f del x square plus del square f del y squared, right? What happens is that we end up getting negative 4x x squared plus y squared to the power of 2 minus 4xy to the power of 4 plus 4x to the power of 5. Okay. Plus 8y squared x to the power of 3 plus 8y to the power of 4 x. Okay. And we have here x squared plus y squared to the power of 4. Okay, interesting. So we have these terms, right? And I think we'll have to simplify them a little bit. So I have here 4x, x to the power of 4 plus 2 x squared y squared plus y to the power of 4, okay, and minus 4 xy to the power of 4 plus, actually wait, I can simplify this a little bit here just to make things a bit simpler. I could simplify this, to be honest, right? I could actually simplify this a bit to 4xy to the power of 4 plus 8y to the power of 4x. So the same as saying it's a 4xy to the power of 4, right? Plus 4x to the power of 5 plus 8y squared x to the power of, was that 3 or was that 5 actually? 3 actually. I suppose it was supposed to be 3, my bad. Over this x squared plus y squared to the power of 4. Okay. So okay, I need to actually erase some of this space here. I think. I mean, let me rewrite del f del x squared for del y squared first, so that I think it's easier for us to see. So it's negative 2x x squared plus y squared to the power of 2. Okay, erase it. But I just want to make sure that these functions are right. Okay, so that's why I'm like writing. Okay, so plus x squared y squared x squared plus y squared square to the power of 4. Let's make this a bit bigger. Okay, so obviously what happens, we would end up having 4x to the power of 5 minus 8x cubed y to the power of 2 minus 4xy to the power of 4 plus all of these terms, right? So 4xy to the power of 4 plus 4x to the power of 5 plus 8y squared x cubed. Okay, if we take this into consideration, over x squared plus y squared to the power of 4, actually we can see that what's happening right here is this gets cancelled off, right? So this gets cancelled off, this also gets cancelled off as well, and this gets cancelled off, so eventually it becomes 0. And as we know it, if we have 0 over something, what's gonna happen? 0 over anything is obviously 0. Okay, so I know I've changed color, but I just want to show you that uh we have managed to prove this. We managed to satisfy this actually. Okay, we've managed to satisfy this right here. It was a bit of messy algebra, I know, I'm quite aware of it, and it took almost 36 minutes, I know, because of the checking and all that. I just want to make sure that we got it correct. And this is quite a necessary step that you have to do for your exams, I would say, or midterm, right? Just to make sure that you are doing the calculation correct and whatnot. Otherwise, if the algebra is wrong, you won't be able to satisfy your answer. This will take a lot of your time. So yeah, we've already proved it. And now we are going to one more question actually before I end this video, right? Just one last question only. And yeah, let me just erase it. Oh, let me just make the eraser bigger actually, by the way. All right. Hopefully it won't be long. Hopefully it'll be a short question, right? Where we got everything correct. Okay. Right. Let's go to our next question. So the next question uh is also a verification question, right? And let's see. So we have to verify. Oh, let me change the color back to yellow, our standard color, right? So we have to verify, okay, that del square f del x del y, okay, del x del y is equivalent to del square f del y del x. Okay, for which function? So we have the first function that we're going to be interested in is f x y, okay, where it's just simply x cos x square cos y. And then we have the second case here, okay, where it is just fxy, okay, it's sine hx, sine hx cos y, okay. So sine hyperbolic, sine h means sine hyperbolic, by the way, okay. So we're gonna first focus on a actually first, right? We're gonna focus on a, right? We're gonna focus on a first, then later we will do on b, right? So let's do on a first, okay. So first of all, uh, we have to find del f and del y. Okay, let me use my yellow color. So we find del f, okay, del x. Del f, del x is very simple. It's just simply 2x cos y. Okay, whereas del f, del y, okay, is just simply negative sine y x squared. Okay, and now when they say in the question del square f del x del y, that means what? That means it is just del x, okay, del f over del y, and this one refers to del y over del f del x. Okay, so uh when we actually find the del square f del y del x, so we're differentiating with respect to y right here. So that means that in this case we'll be interested in the, let me mark in orange, the cos, right? So in this case it become negative 2 sine y, right, times x. And this one, okay, del square f del x dy is, so we're really interested in differentiating the x square here, okay? So in this case, it will become negative 2x sine y. So as you can actually see, if I'm going to mark in white, or can I mark in, was I mark in white already? That this and this are the same, right? These are the same. So they're the same, therefore, we've already verified that for A. Pretty straightforward. Now let's try to go for B. Okay, let me erase all this. It's pretty straightforward. Now let's go for B. Okay. Okay. So for B, let me get my pencil over here real quick. So for B, it is fxy. If you recall correctly, it was sine hyperbolic x, sine hyperbolic x cos y. Okay. So we're gonna find del f del x. So in order to find del f del x, since we're only interested in the hyperbolic function of sine, so we need to thoroughly differentiate that. The cosine will be just a constant, by the way, so it'll just be cos y. And hyperbolic sine h, I need to actually refer back because I don't really recall what is the hyperbolic, but I can check. Right, so it will just be sine hy differentiation, differentiation. Okay, sorry, sine hx to be honest. Uh, wait, so this is sine hx actually. Yes. So the derivative of sine hx actually uh is just simply cosine of hx. Okay? If I'm not mistaken, let me just double check right here to see the derivative. Derivative of sine hx is cosine hx. Okay. So let me just double check. It's inverse, by the way. This is not the normal function. Sine hx cosine hx. Okay. So in this case, our derivative is obviously cosine hx. Okay. And for del f del y, since we're only interested in uh the cosine y, right? Because the sine hx is not important to us. So it is just going to be negative sine y, okay, times sine hx. All right. Now we want to find del square f over del x del y. Okay. So in this case, we want to only find the, sorry, I think I mixed it up. It's supposed to be del y over del x. Okay. Right. So we only want to differentiate y. In this case, we only want to differentiate. Let me just highlight this in blue. I only want to care about this one, by the way. Right. So in this case, this will become negative sine y cosine hx. Okay. And for this one, del square f, del x, del y. Okay, we're only interested in uh, this one, sine hx. So in this case, we already know the derivative of sine hx is cosine hx. So it's just negative sine y cosine hyperbolic x. So we can clearly see also that, this one and this one are the same, right? They are the same. So that means we've already proved that this is the case, right? So that's it for the third video where we talked about successive differentiation. And honestly, thank you for you guys for listening to this video. If you guys have any questions, feel free to reach out to me on WhatsApp or on MS Teams, right? So thank you for listening. I apologize for any background noise and obviously some recording mishaps there because that's something I can't really control. But yeah, till then, thanks for watching. Right, see ya.